What's up, guys? Today we're going to be solving quadratic equations by completing the square. So there is one thing you're going to want to be comfortable with coming into this, and that's how to factor a perfect square trinomial. But if you can do that, then you'll be good to go. Alright, let's check it out. Alright guys, completing the square is one of the few methods that you learn to solve quadratic equations. And generally the first method you learn is factoring. And it turns out that factoring is actually the most efficient way to solve this equation. This trinomial here does factor. But for purposes of this video, we're just going to use this example to demonstrate how the mechanics of completing the square works. And so the first step to completing the square is to get your x terms alone on one side. So right now I have my x terms together on one side, which is good, but I also have this constant term with them. So I'm gonna kick that over as my first step. So I'm gonna subtract 20 from both sides here. And that's just gonna leave me with my x terms on the left side and negative 20 on the right side. Now this turns out that's not a necessary step. There is a way to do this without doing that immediately, but I think that way is a bit more confusing, so we're just going to stick with this for now. And so now that I'm in this position, now I can go ahead and actually complete the square. So I'll probably make another video going through the concept of completing the square and how it works, and more specifically why it works. But right now we're just going to get into the procedure. And so the first step to completing the square is you're going to take this number here. In the context of quadratics, we call this the b value, right? The coefficient of the x term. So you're going to take this number here that's multiplying your x, in this case negative 12. You're going to cut that in half. So we're at negative 6. And then we're going to square that number. We're going to multiply negative 6 by itself. And so that gives us a positive 36. And then with that positive 36, we're going to add it to both sides. Okay, so again, I took this number. The number that multiplies x is called the b value. We cut it in half, so that's negative 6. And then we multiply negative 6 by itself to give us positive 36. So we added 36 to both sides. And you'll see why we do that in just a second. And that's going to give me a positive 16 on the right side here. Negative 20 plus 36. All right. So now we're about to get into why we did this. So why did we strategically add this 36? Well, you'll see now that this is a perfect square trinomial, which means it factors into a binomial times itself. So if you were to factor this trinomial, you would get x minus 6, the quantity squared. Okay? And now what we can do is we can sort of now take on the mindset of getting x by itself, right? Solving for x. And so how do we get x by itself? Well, we have to get it out from under this exponent first, right? So I want to undo this exponent by taking the square root of both sides, right? Whatever you do to one side, you have to do the other side. And this radical is going to cancel the exponent. Okay, so now I'm left with just x minus 6, and that's going to equal the square root of 16. We know is not only positive 4, it could also be negative 4, because not only does 4 times 4 give us 16, but negative 4 times negative 4 also gives us 16. So we have two possible square roots here on the right side. All right, and now we're one step away from getting x by itself. So to get x by itself, we know we have to add 6 to both sides. And so now we have two possible answers. We have plus or minus 4 plus 6. And so we're going to do this in two separate cases. So positive 4 plus 6 is 10. But then we have to do negative 4 plus 6, which is positive 2. And so we have two solutions here to the quadratic. We know that x could either be 10 or it can be 2 to make this a true equation. Okay, now I'll move on to the next example here. So remember, just like we did on the left example, step 1 should be getting your x terms alone on one side. So since my x terms are on two different sides, the first thing I'm going to do is add 10x to both sides. And now that my x terms are together on one side, I want to get them alone on that side. So I'm going to subtract 18 from both sides. So this is all just set up right now. And now we can go ahead and complete the square. So I'm going to take my b value, right, the number that multiplies x, and I'm going to cut it in half. So that's going to be 5. And then I'm going to multiply 5 by itself. I'm going to square it, and that gives me 25. So I'm going to add 25 to both sides. And that's going to give me positive 7 on the right. And now, just like the last one, the purpose of completing the square was to make this a perfect square trinomial that we know can factor. And that's going to factor into the quantity x plus 5 squared. All right, and now we can go into solving mode, right? We're trying to get x by itself. So how do we get x by itself? Well, we have to first get rid of this exponent. So to undo the squaring, to undo that exponent of 2, we're going to take the square root. And whatever you do to one side, you have to do to the other side. And now I've canceled this exponent on the left side, so I have x plus 5. And now here, we don't know the square root of 7 without a calculator. Okay, this is an irrational number. And so we're just going to leave it as plus or minus the square root of 7. Okay, because again, the positive square root of 7 times the positive square root of 7 will give me 7. But the negative square root of 7 times the negative square root of 7 will also give me positive 7. Okay, so we have to take into account both of those cases. And now we get x by itself by subtracting 5 from both sides. And so x is just going to equal negative 5 plus or minus the square root of 7. Or I could have also have written this as plus or minus the square root of 7 minus 5. Either way is fine. The reason I chose to write it this way is just so that we don't think that the negative 5 is underneath that radical by mistake. That's the only reason I put that out in front. But this is what we call an exact answer. So since we don't know the square root of 7 without a calculator, this is as simplified as this solution will get. Just keep in mind that this is two solutions, right? It's negative 5 plus the square root of 7, or it could be negative 5 minus the square root of 7. And so that's all there is to it, guys. It's been demonstrated.